The function is the module of software in the C language. We use functions to write chunks of reusable code with a fixed interface. So we write code that takes in some multiple number of input values, 0 or more, and produces 0 or 1 output values. So from the user's perspective, they provide the input, they get the output, they don't know what's going on inside this code. So we can modularize our code, write, make changes, and so on, as long as it meets the interface. We can have different implementations of a single function. When we use a function, we call it, we say we call the function. So from the caller's perspective, the job is we copy values into each of these input boxes here. And then we turn the switch, transfer control over to the function, and some magic happens, and it produces an output value. And then when control returns to the caller simply copies that value out and uses it as part of an expression or a statement. From the function's perspective, once it starts executing, these values, these boxes here have values in them that the caller put in. And these boxes are treated just like local variables. So a variable is one of these boxes that has a value in it. That's what we have. So we have those values available to us, and we use them just like local variables. When we're ready to produce the value that we want to return, we use a return statement, and we provide an expression that represents the value that we want to be placed into this box. The return statement also transfers control back to the caller, which will then copy out the return value. In terms of the C language, there are 3 components to using functions. First, we need to declare a function. We need to tell the compiler what the function looks like. So here's an example. We have a function that we are calling compound. We're going to do calculate compound interest. We tell the compiler when this function is called, it's going to return a value of this type, double. And we expect input values of this type, 3 input values, a double, and an int. And we might put names on here to help the reader of the code understand what those values should mean, but these names are actually optional in the call and in the declaration, as we'll see in a minute. So what this declaration statement ending in a semicolon means is that we are going to at some point have a function named compound. It takes a double, and an int. And the user of this function understands that the first double is the principal value amount, and the second double is the interest rate. And the integer value is the number of periods we're going to compound interest over. So with this information, someone writing code knows enough to use this function, to call it. We call it with this expression right here. We say the name of the function, parentheses, and we put values in that will be passed in for the different input values of the function. So here we use a variable. Here we're using a literal value, 0.05, which is a floating point value. And here we are calculating a value, end minus start, to see over how many years or periods we want to compound the interest. So this expression from here to here is the function call, and then that expression is combined with other expressions in a statement. So here we have an assignment expression. We take the result of this function call and assign it to our local variable called uval, and then we end the statement. So that's what a function call looks like. The third piece that we need is to define the function. We need to tell the compiler what code should be executed when this function is called. And the beginning of the definition looks very much like the declaration. We have a return type, we have a name, we have a type for each parameter, and a name for each parameter. In this case, the names are not optional, they're required. These names are used of variables that get bound to the values that get passed in. So the value of balance gets passed in inside the function, that's called P. 0.05 gets passed in inside the function, that's called R. And the expression n minus start gets passed in, and that value gets bound to the name T. Then we start the code part of the definition with an open brace here. We can declare local variables. Here I've declared a local variable I. I have a for loop that changes I from 1 to T. And each time I do that, I multiply P times 1 plus R and save the result in P. So when I do that, I compound the interest, and P at the end contains the value that I want to return. So I use a return statement, return P, and that gives control back to the caller. So this is what a function definition looks like. Function declaration, function call, function definition. We'll look at a little more detail of these three things. The declaration tells the compiler what the function looks like. What do we need to know? What does the compiler need to know? The compiler needs to know what type of value is going to be returned, what's the name of function, and the type and number of the parameters, the values that are going to get passed in. So the types of the parameters are required because that's what the compiler needs to know. The names of these parameters are not important to the compiler. It doesn't use those names for anything. So you may provide those names to help the reader of your code know, oh, the first parameter means this and the second parameter means this, because they both might be integers and it might not be clear on what kind of value, what does that value represent that you're passing in. You can create a function that does not return a value. So you might write a function whose job is to print something, right? So it has a side effect. It does something, but you're not calculating a value that you want back. And if that's the case, then the return type is called void. So you would just write void and then the name of the function and look at it that way. Also, you might not have any input values, and if so, you just close the parentheses right there. You don't have to provide parameters. It might have 0 input values. The function call looks like this. We say the name of the function, open paren, and then we have a series of expressions, one for each input parameter. So the number and types of these argument values, arguments are bound to parameters, must match the declaration. So the call does three things. It provides values, it writes those values into the boxes for the inputs. It transfers control to the function, and then when the function gives control back, it retrieves the return value from the function and uses it. So the value associated with this expression is the value that's returned by the function. And the syntax of a definition looks like this. We have to give the return type. We give the name of the function. And again, we have the type of each parameter and the name of each parameter. This time the name is not optional. It must be there because we're going to use those names inside the function to refer to that value, the first value, the second value, the third value, and so on. These things, the types, the number of parameters, the name, the return type, they all have to match what the declaration says. Then we open the code with a curly brace. We declare any additional local variables that we need to implement the code. And then we just start writing statements for using the input values and manipulating them and creating whatever it is that we want to return. When we're ready to return, we use a return statement, which looks like this. The keyword return followed by an expression. That's the expression that will be bound to the return value when our function returns, and the type of that expression needs to match the type of value that we said we were going to return. And we end that with a semicolon. Now, I've shown the return statement as the last statement in the implementation. That may not necessarily be the case, and you can have multiple return statements. So you might have an if condition: if something's true, return this, else do some more work and return something else later. So there's no restriction on how many return statements might be in a function definition, but when we execute the return statement, the function's finished. It returns control to the caller, and we no longer execute any statement beyond that.